Libby and Haley.
Hello, Libby and Haley. We are doing the last little bit of the notes for section 5.2. I am X-naying this assignment out of the book, and I gave them a piece of paper that looks something similar to this for homework problems. So there's like 12 homework problems, all antiderivatives, but we're going to go through the last little bit of notes. We are out here in the beautiful sun. Actually, we're in the shade right now. So I'm going to go through these guys, and then we will do homework stuff, whatever, okay? So this little diagram, this little graphic that they have going on right here, those are the same curves, right? Each one of those little guys is the same curve, except the y-intercept is different. So this is the graph of 1/3 x cubed plus c.
So it's
and
same
all
x,
this is
different y.
saying is that whatever my plus c is, that tells me what my y-intercept. So one of them is 1/3 x cubed plus 2, 1/3 x cubed plus 1, 1/3 x cubed plus nothing, 1/3 x cubed minus 1. All of those, and they are saying that all of these graphs right here will have the same derivative. True? Because the constant, the plus c, will end up dropping off the end when you take the derivative of him. So that's just going to show you that all of those are going to have the same derivative. All of those are antiderivatives of, what was it, x squared? These are all antiderivatives, all antiderivatives. And those are all antiderivatives of x squared function, whatever, okay? Every one of those is the same thing, okay? All right, example 5. Example 5 and example 6 are a little bit weird in that they say, okay, suppose that a curve in the xy plane has the property blah, blah, blah on the curve and has a slope of x squared. So the slope of the tangent line is x squared. That means the derivative, that means the derivative equals something, right?
Plus c.
If the derivative is x squared and I'm trying to get back to the original function, how do I go from derivative to original?
Antiderivative.
You take the antiderivative of x squared, which we know is 1/3 x cubed plus c, right? Okay, so I'm going to do one more, and I'm going to say the equation will be y equals 1/3 x cubed plus c, right? Like that's what he will be, right? If I write him out as a function. It says find an equation for the curve given that it passes through the point 2, 1 specifically. So
now we plug
all
those in.
of these are going to be like antiderivatives, but which one of those is going to go through the point 2,
So we
1?
just plug it in for the x's and the y's.
And solve for
C.
c. Yeah, we're plugging in 2 for x and 1 for y.
Minus 1.
Yep. So 1 equals 1/3 times 8, which is what 2 cubed would be, plus c, okay? And this will be 8/3, okay? If I then subtract 8/3 to the other side, okay, minus 8/3, I'm just gonna do like 1 would be 3/3. 3/3 minus 8/3
Negative 5/3.
would be negative 5/3. So c would be negative 5/3. And my specific original function that is going through that will have a derivative of x squared is this one right here. Specifically the one 1/3 x cubed minus 5/3. That is the one that's going to go through the point 2, 1 that has a derivative of x squared. Make sense? So they're just saying now you don't have a plus c on the end, you actually have a number in place of your c value. Got it? Not on that homework. Let's do the last one. Example 6 is kind of the same way.
How do we do this with
Except,
cosine?
yeah, except this one says your derivative is cosine. So dy dx, that's another way of saying that the derivative equals cosine. If I'm trying to get back to the original guy, I take the antiderivative, okay? And do you know what the antiderivative of cosine
Negative
is?
sign?
The derivative of cosine is negative sine.
It's sine.
But it would just be positive sine because the derivative of sine is cosine, right? The derivative of sine is cosine. Okay, so
sine
now
x
I have y equals sine x plus
plus
c.
c.
Okay, what does this thing mean? Y
That
0
means
equals 1.
0 is y.
This is the
X
point
is y.
0, comma 1. X is 0, y is 1. So I'm plugging those in particularly, okay? So 0 goes in for x. 0 goes in for x. 1 goes in for y. Okay, do you know what sine of 0 is?
1.
Okay, 0 is right here, and sine, like 0 would be right here. This would be the point 1, comma 0, right? That coordinate right there, 1, comma 0. And sine is the y coordinate, so he will be 0. So 1 equals 0 plus c. So C is
1.
1. And the particular answer or the specific answer, that is y equals
Sine X
sine
plus
x
1.
plus 1. That is what your function is that particularly goes through that point. Got it?
Yep. Sweet.
So sometimes they might give you a point and say find C exactly, okay? So here is, and I don't know if you girls, I can give you a paper that looks like this, but these are the 12 problems. If you wanted to like pause this and write those down, then you wouldn't have to come get a paper from me and you could kind of work ahead. But there is that. 1 and 2 are just going to be similar to the ones that we did the other day, like where I would quiz you and say find each one of these derivatives. But some of these other ones you have to kind of be a little bit like manipulated a little bit. Like number 3, I would take that x to the 6th power and move him up to the top and make him x to the negative 6th power before you take the antiderivative, right? So sometimes you might have to rewrite these. Like number 4, how do you rewrite number 4?
X to the 4th.
X to the 1/3.
Wait, which one are we on?
And then dx. So like rewriting, just like how do you rewrite number 3 and how do you rewrite number 4? I skipped over 1 and 2.
I was on 1.
Okay. What about 5?
Did I do it right? Do you distribute?
For that guy, probably.
I'm not missing
Yes,
anything, right?
yes. A plus C.
Oh, plus C.
Yep,
Yes.
yep. Okay. Number 5. What do you do for number 5? Yeah, let's distribute him. Okay. So x plus x to the 4th, and then you would do the derivative. Okay. So some of these might require you to simplify them a little bit.
That's just half x squared plus
I've heard how to do
1/5
this.
x to the 5th.
Plus C.
Yeah, I do this right.
Okay.
How do I?
Oh, if you need the formula, it is 1 over n plus 1 x to the n plus 1 power. So maybe you write that down somewhere on this page. 1 over n plus 1 x to the n plus 1. So whatever your exponent is, 1 over n plus 1 x to the n plus 1. Okay.
I have.
Like number 4.
Yes. So 1 over 4/3, when you simplify that whole thing, would end up being 3/4. So it would be 3/4 x to the 4/3 then. That makes sense? Yeah, plus C. Don't forget your plus C's.
Is that a plus?
Okay. I will tell you 9 through 12, you might have to get a little creative. And you might have to use, and these are not going to use the 1 over n plus 1 x to the n plus 1. Those are going to use formulas that are on this sheet right here. Your integration formulas. It's going to be like trig functions and stuff.
Break down?
9, the bottom 4. 7 over 5.
Does that get simplified anymore or no?
No, I would leave him that way. Oh. What are you talking about?
Like does he
Yes,
simplify?
yeah, I see what
He
you're doing.
does simplify or no? He does not. Just leave him.
I don't know what you're doing.
-7.
Oh, yes. Just leave him like that. Yep.
X to the 5th. So we're talking
Yep.
about. Yeah.
Okay. So there you go. Okay.
Minus x to the 3rd plus half x squared minus 1x plus c.
Okay, I might stop the recording because I think everybody else is working all good and fancy now. Okay? All right, so that's all I have.